Saxon's Trig, lesson 115, is about the remainder theorem. Now, thankfully, this is still using synthetic division, so I can use my shortcut of things. And the last time we did synthetic division, we were looking for zeros, so that we wanted a zero as the last number for the remainder. And if that was true, then whatever I was testing was an answer or a zero to the equation. In this, they're going to use example 1 to prove to you the remainder theorem. So use the polynomial equation f of x equals x squared plus x plus 4 and a divisor of x minus 3 to do a specific development of the remainder theorem by showing that in this case, the remainder equals f of 3. So we're going to start with our synthetic division. We're testing 3 because we're pulling it away from the x. Highest exponent value is 2, so coefficient is 1. So x squared, plain x is also 1. Non-x is 4. Drop our 1. 3 times 1 is 3. 1 plus 3 is 4. 4 times 3 is 12. 12 plus 4 is 16, so I have a remainder of 16. So this is the number I care about at the moment. Now to prove it, it's saying take this 3 and plug it into the equation, and what do you get? So f of x equals 3 squared plus 3 plus 4. Well, that's 9 plus 3 plus 4. That is also 16. So f of x equals 16. So what they wanted me to show was that the number I get here at the end of a synthetic division is the same as I get when I plug the 3 into the equation. That is the remainder theorem. Whatever the remainder is the answer for plugging in 3. Now, example 2. Use the remainder theorem to evaluate 2x cubed minus 8x squared plus 3x plus 5, and they want us to say x equals negative 4. So negative 4 is what we're testing. So in my division box, it's not attached with an x, so we're going to keep the negative 4. X cubed is the highest value, coefficient is 2. X squared, it's negative 8. Plain x, it's 3. Non-x, it's 5. Drop our 2. Negative 4 times 2 is 8. Negative 8 plus 8 is 0. Just a second. Nope, I didn't feel that felt right. Negative 4 times 2 is negative 8. Let's try that again. Negative 16, that felt better. Negative 16 times negative 4 turns it into positive 64, so 67 when I add it. 67 times negative 4 is negative 268. Add with 5, that's negative 263. So that is the answer for plugging in negative 4. So is that not a beautiful, quick and easy way to do the calculation without having, well, to be able to use the synthetic division? Now, example 3. Use the remainder theorem to evaluate x to the 7th minus 4x to the 4th plus x minus 3, and x is 2. So in our synthetic division, the box is 2. X to the 7th is the highest, coefficient is 1. Then I need x to the 6th, which I don't have, x to the 5th, which I don't have, x to the 4th, which is negative 4, x cubed, which I don't have, x squared, which I don't have, plain x, which I have as an implied 1, and the negative 3. Drop our 1. 2 times 1 is 2, adds to 2. 2 times 2 is 4, adds to 4, multiplies to 8, adds to 4, multiplies to 8, adds to 8, multiplies to 16, adds to 16, multiplies by 2, 32, adds to 33, multiplied by 2, 66, adds to 63. So 63 is the answer when I plug in 2.